I actually forgot one thing I had prepared when talking about as you take the limit as your x approaches a number. So I'm going to go and go over this just because it maybe help clarify some things. This was a problem that I handed out the past couple years. This will just take a few minutes. I should have stuck it on the last video, but I forgot. So there's 4 graphs, and along the side for each of these 4 graphs, we're asked the same 4 questions. So let's just go through these. I won't even describe it. We'll just do these problems. So here, notice the first graph, function x, sort of a curvy graph. Now you notice this one, when x is 4, there's a hole here, so there's a gap or a break in the graph right at x equals 4. So let's see if we can answer these questions. So as we're doing this, hopefully you can, in your own mind, think what the answer would be. This first one says, what is f of 4? What's the function when x equals 4? Well, x equals 4 is right here. I go to my graph. What do I find? It's a hole. In other words, this function, this graph does not exist when x equals 4. What is this one? This says, let's go look at the limit of the function as x approaches 4 from the high side, right? From the positive side. So x is approaching 4. 4 is here, so I'm going to start up here. I'm coming from the high side. And as x gets closer and closer to 4, what's the value of my function? Looks like I'm approaching 5. The next one says, how about the limit of the function when x approaches 4 from the low side? All right, so if here's x is 4 from the low side means I go here. What is the function I'm approaching when x gets close to 4 from the low side? It's 5. And then the fourth question, they say, what is the limit as x approaches 4 of the function? In other words, now it's the overall limit. Here it's the limit as you're approaching from the high side, the limit from the low side, overall limit. Well, there's 2 things. You can look at the graph and see it, or you could also say, well, you know, if the limit from the high and the limit from the low are the same, then you know there is a limit, and it's 5. And you look at the graph, it makes sense, right? Even though, here's the key, even though the function is not defined when x equals 4, however, at x equals 4, there is a limit because the graph or the function from both sides is approaching the same value, which is 5. So these are the same 4 questions for these other 3 remaining graphs. So it shouldn't take us quite as long. The second graph, sort of interesting, it's identical to the first one, except we have a hole here, but you notice that there's a point way up here. So when x equals 4, there's the point way up here. So this first question, what's the function when x is 4? It's this point right here. So it's actually 10. And then the same 3 questions. As x approaches 4 from the high side, it's the same as the first problem. It's 5. As x approaches 4 from the low side, what's the function? 5. So therefore, what's the limit of the function when x approaches 4? High and the low approach the same value. You can see from the graph. So what's interesting, even though when x is 4, the function actually equals 10, but the limit as x approaches 4 is still 5. Because once again, the limit is not asking what is the function at that value of x. The limit is asking what is the function as you approach that value of x. All right? Hopefully that's clear in your mind. How about this one? The difference here, this one, the same curve, but now there's no gap, no break. It's just all continuous. So what's f of 4 here? It exists. There on the graph, it's 5. Coming from the high side, it's 5. From the low side, it's 5. Therefore, what's the limit? 5. Now this last one, the actual graph sort of changed, not the same shape. This first part, this is almost like a piecewise function, right? Here's the first part when x is less than 4. But then when x is 4, it jumps up here, and then it goes from there. So if you look at our questions, what's the function when x is 4? It's not here, it's up here. It's the closed circle. So it's 10. What's the limit as you approach x equals 4 from the high side? We're up here, right? As x approaches 4 from the high side, what's the function approaching? What number am I approaching? 10. How about when I approach x from the low side? What am I approaching? What number for the function? 5. Now obviously from looking at the graph or these numbers, we're not approaching the same value of the function from the high and the low side. So obviously there's no limit, which is also obvious from the graph. All right, so this is a good little exercise, hopefully to cement the idea of what's involved in looking at limits when you approach a number.